Okay. So can you see my screen?
Yes, ma'am.
Perfect. Okay, so today we'll again talk about differentiations, but before going to the new topics, I'll first give you a quick recap. So by now we have discussed all of these differentiations. Okay, so let's just quickly revise. This was the product rule. The product rule is applicable whenever you have two functions of x or t or any other variable and they are being multiplied. So let's say you have f of x and you have g of x. So in such cases, whenever you have been asked to differentiate such a question, you use the product rule. So what is the product rule? First function comes as it is. F of x would come as it is. We have to write down the derivative of second function plus second function would come as it is, and we'll write down the derivative of first function. Okay, this was the product rule. Similarly, if we have a fraction and we have been asked to differentiate it, this now in the product rule we can use any function as f and any function as g, as in I could have written this as well, g of x f dash x plus f of x into g dash x. Okay, in case of multiplication the order doesn't matter, but when we're talking about the quotient rule we have to be very careful that the first function would be the denominator, we have to derivate the numerator, we have to subtract it, and the numerator would come as it is, then we have to derivate the denominator divided by denominator squared. So here the order is important, right? Okay, then we discuss the derivation of this exponential function. So here we have e to the x. Derivative of e to the x would be e to the x directly, but the rule was if we have e to the f of x, the derivative of such a function would be e to the f of x would come as it is, and we need to multiply the derivative of this exponent. Okay, exponent in this case is f of x. Exponent is basically the power, right? Let's talk about these trigonometric functions now. This is sine x, derivative of sine x is cos x, derivative of cos x is minus sine x, but this is for sine x. If we have sine f of x, we simply have to write down cos f of x, and the derivative of f of x would come here as it is. Okay, but if we have sine square f of x, we need to solve it by using the bracket rule. When I say bracket rule, I mean whenever we have a function in brackets, let's say we have f of x whole square and we have been asked to differentiate it, we do it this way. 2 would come as it is, f of x into f dash x. Similarly, we have sine square, so 2 would come as it is, sine x f of x. Then the derivative of this function is basically cos f of x into f dash x. Okay, is it clear now?
Yes.
Perfect. Okay. Next, we discussed the derivation of tan x. It's simply secant square x. Okay, and the derivative of tan inverse. Do you remember? The derivative of tan inverse, we discussed this in our previous class.
Yes, the derivative of tan inverse is tan x by 1 plus
Tan x or simply 1 plus x square.
1 plus x square. Yeah.
Excellent. And what if I talk about a function that is, a general function? What if I had f of x in place of x over here? How would we differentiate that? Let's say if we had tan inverse f of x. We should know how to differentiate a general function. Okay, so again 1 divided by 1 plus f of x whole square into f dash x. Okay, this is what we have been discussing, right? Is it clear?
Yes.
Okay, then sine ax plus b, the sine is cos basically, so cos ax plus b would come as it is, and a is the derivative of this function, so we have multiplied it over here. Similarly, derivative of cos is minus sine, and the derivative of this function is a. And for tan ax plus b, secant square ax plus b into derivative of this angle. This is basically the angle, okay? X plus b, whatever we have after a trigonometric function is simply called an angle. We usually write cos theta, sine theta, so these are basically the thetas, right? Is it clear?
Yes.
You can ask me anything you want to, okay? Because this is a recap of what we have already discussed.
Yeah.
Okay, perfect. So let's talk about the two homework questions you were not able to do, and rest of your homework was correct. I only need to tell you one thing, but I'll discuss that later. Okay, let me just write. So question 1, derivate 5x plus natural log to 1 minus 2x. Okay, this was the question. Let's talk about the solution now. Okay, so I need to change the color. Let's use blue color now. Right, let me just, highlight the question properly. So we have been asked to differentiate this whole thing, okay? Let's talk about the solution. What is the derivative of 5x? It would be 5 simply, right?
Yes.
Plus, okay, and what was the natural log rule? If I talk about the general rule, I want you to answer me, please. How do we derivate this type of function?
Ln of f of x is 1 by 1 plus x.
No, 1 by 1.
F dash of x.
Sorry, what am I going to write over here? 1 by?
1 plus f dash of x.
Wait, I'll tell you. This is the rule for natural log. 1 over this function would come as it is, and the derivative would come here, okay? You are mixing up the rule for tan inverse f of x. When we are differentiating such type of a function, we have 1 plus f of x square into f dash x, okay? Be clear with the functions. So here we are talking about the natural log function. Simply 1 over f of x, 1 over the function which we have after natural log would come here as it is, and we need to simply derivate it. Right? Is it clear?
Yes.
Okay. So according to this general rule, how are we going to differentiate our given question? So the general rule says we need to write 1. Okay, we have written 1. What is f of x in this case?
F of x is 5. No.
Just look at this part. Just look at this part, okay? And look at this part. Here we are talking about the derivative of this.
-2.
Wait. Here we are talking about the derivative of this part. We have already written down the derivative of 5x, that is 5. Now we are discussing the derivative of this natural log function. For natural log function, this is natural log and this is f of x. So the function that comes after natural log is basically the f of x, okay? This is natural log and this is the function that is coming after natural log. So this function is f of x, right? Is it clear now? This whole function, this fraction is f of x. Is it
So
clear?
can we write it as 2, 1 minus 2x to the power negative 1?
Yes, exactly. 2, 1 minus 2x to the minus. Okay, but what is this? Is this f of x?
Yes.
Excellent. So this is f of x, okay? So we can simply write down 1 over f of x as per the formula. I'm not explaining new things, it's just what we know. We are just applying the formula, okay? Minus 1. And now we need to write down the derivative of f of x. So this is f of x. This is f of x. And we need to write down the derivative of f of x. So simply we have to use the bracket rule. By bracket rule, I mean the power would simply come here. Minus 1 into this 2 was already there. Okay, you don't have to use the product rule in this case. We use product rule. This is what I have noticed in your homework. The answers were correct, but the product rule is used in those cases when both these functions are of x. This 2 is not a function of x, so you don't have to consider it as g of x or f of x. Okay, it's simply,
Oh, okay.
yeah, excellent. So this 2 would come here as it is, okay? Now we will write down the bracket thing like this, and we have to subtract minus 1 from the existing power, and the derivative of this bracket would come over here, okay? So what is the derivative of this bracket? Minus 2, right?
Minus 2.
Excellent. So the answer
Yeah.
is 4, 1 minus 2x minus 2. This is the f dash of x. And where am I going to write down this f dash of x? Just look at this general formula and tell me.
You're gonna multiply it with 1 by
Excellent.
2 times. Yeah.
4, 1 minus 2x minus 2. And this is 2, this is 1. So we have 5 plus, this is minus, this power is minus. I can take it to the numerator to get this, right?
Yes.
So I have taken this to the numerator and I'll take this to the denominator because it is minus 2. 1 minus 2x square. So simply I will just cancel these, and my answer would be, and yeah, we have this 2, okay? This 2. So the answer is 2, 1 minus 2x. Okay, is it clear? This is the answer. Okay, so Ranjani, you are an excellent student. But the only thing I think you are lacking at is the practice, right? You have come across these questions for the first time, and obviously, you are a human. You cannot memorize everything, and you don't have to. All you need to do is you need to practice. Your homework was excellent, everything was correct. Only this thing I wanted to tell you, that if we have two functions where the first one is has x, only then you have to solve it as the product rule, by using the product rule. If you have 2 into 1 minus 2x to the minus 1 or something of this sort, if you had a function like this one, it is not going to be solved by product rule. You can just directly solve it. Another thing, just remember that whenever we have natural log, we'll be having a function after natural log. This function is f of x. And once you have been asked to differentiate this natural log thing, all you need to do is you have to write 1 divided by this whole function would come as it is. Simply you need to find out the derivative of this function and you have to multiply it over here. Is it clear?
Can you repeat it?
Yeah, sure, I can. Okay. So I'm telling you that whenever you have been asked, let me just um, get a new whiteboard just so I can write things clearly. Okay, it's loading. Let's talk about exponential function, natural log function, and tan inverse function. Okay, I'll be explaining only these three functions. We have already discussed these, but just for the sake of completeness, right? This
We don't
is,
have cos inverse or sine inverse. Is it the same thing?
sorry.
The rule we follow for tan inverse, is it the same? Do we follow the same rule for sine inverse and cos inverse as well?
No, 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 no. No, the that differentiation would be different. I am sorry if I was supposed to explain that as well. I just followed your the contents I could see through that page. I'll explain those as well, okay? The derivative for sine inverse and cos inverse. I'll explain those as well. Let's just discuss this first. Then I want you to share your book. Did you get the PDF version of your book?
No, the PDF version of my book is not available.
Okay, that is
But
okay.
even in my book, I didn't come across sine x or sine inverse of x and cos inverse of x. It's
I did not understand what are you saying? You haven't come
I
across or you
have,
have?
no, I haven't come across any rule for sine
Yeah.
inverse of x
Okay.
or cos inverse of x. It's only tan inverse of x. I was just
Exactly.
wondering.
Yeah, yeah, yeah.
Yeah,
Okay, okay, that is perfect. I can explain that as well. Not no problem at all. But first, let's talk about these, okay?
yeah,
And I'll explain those because these are already new topics. So I want you to, get used to these now, just so we can move on to the integration chapter as well. But don't worry. Obviously, understand you are looking at these differentiations for the first time. Okay, e to the f of x divided by dx. Okay, so here I have three types of differentiation questions. The first one is the natural log question. Now listen, whenever you have been asked to differentiate a natural log question, just remember this is ln. This is natural log. The thing which is written right after this natural log, no matter if it is a fraction, it could be a fraction, it could be a simple expression, okay, it could be a product, it could be anything, it could be any function of x. All you need to do is write down write down f of x, and you simply have to find the derivative of this function. Okay, so for natural log, you'll have natural log, you'll have ln. After ln there will be a function. That function could be a fraction, it could be an expression, it could be a product. You simply need to just note down f of x. Let's say f of x is 2x. So you will, so the question would be ln 2x, and you would have been asked to differentiate this. Okay. So 1 over 2x, because 2x is the function that is written right after ln. And now you have to find the derivative of f of x, that is 2x, because this 2x is written after ln. The derivative is 2, and the answer would be 1 by x. Okay, this is how you need to understand the general rule. This is the general rule, okay? And then you need to apply it for every question. Okay, this is why we learn general rules, because they are applicable for every question. Is it clear?
yes.
Perfect. Now let's talk about the tan inverse. If you have tan inverse f of x and you've been asked to differentiate it, okay, so I will write down a few examples. Let's say you had this, or maybe you had this. What are f of x in these cases? F of x is the function that is written right after the tan inverse function. It can again be a fraction, it can be an expression, it could be a product, right? So here f of x is 1 by x. Here f of x is 2x. What is the rule? What is the rule to differentiate these tan inverse questions? The rule says you have to write down 1 divided by 1 plus this is f of x. This is the function that you have after tan inverse. So you need to square this function like this, and here you will be writing down the derivative of this function. Okay, So this is a general rule. Now let's see how to apply this rule for this question. Okay, let's talk about this question now. We have the general rule. Now we'll see how can we use it for a particular case. Okay, so we have 1 divided by 1 plus, what is f of x in this case? We don't know what is f of x, but what is the function that is coming after tan inverse? This whole function is coming after tan inverse. So we need to write down this function as it is and its square. Next part is to find the derivative of this function. F of x was 1 by x, that is x to the minus 1. So the derivative would be minus x to the minus 2. So we have minus 1 by x square, right? Do you understand now?
Yes.
And then we'll simply be simplifying this, okay? And now let's talk about this. If you have been asked to find the derivative of an exponential function, this is the exponential function and it has something as its exponent. That something in this case is f of x. That something can either be a fraction, it could be a product of f of x and g of x. When I'm writing f of x, g of x, it means in the power of e, we have two brackets or we have two terms that are being multiplied with each other, and every term has something in form of x, in terms of x. Okay. So for such some things, we write down f of x and g of x. You need to be clear with this. Okay.
Yes.
So the rule is e to the f of x would come as it is, and the derivative of this exponent, that is f of x, actually would come here, right? Derivative of f of x is f dash x.
Yeah.
Are you clear now?
Yes.
Perfect, excellent. So let's do the second homework question now. Okay, I would suggest you to write down, take a white A4 paper, use colorful markers and write down these derivatives and paste them on your cupboard or anywhere in your room. Just so, whenever you wake up, you're walking, you're going somewhere, you'll see those time and again and they will help you. It will help you to learn these, okay?
Yeah.
Okay. So this is the second homework question. We have to differentiate this expression. And what is the expression? 3 cos 4x plus 2 tan square 2x minus pi by 4. Okay. This is the question which you were asked to differentiate. Okay. And this is how we are going to do it. Okay. So this is a plus sign. First, we will differentiate this function, then we will differentiate this function, and we are simply going to add the answers. Okay? Right.
Okay.
So let's talk about the solution now. We have 3. 3 would come here as it is. Now this is cos to the 4x. You cannot write minus sign to the 4x directly. Never ever do that. Okay? We are going to solve it like a bracket. So simply 4 would come here and we would be left with cos x whole cube. Now we need to write down the derivative of this function. What is the derivative of this function?
Negative sign.
Excellent. Negative sine
Yeah.
x. Okay.
Yeah.
Plus, we are done with the derivative of this part. Now we have to find the derivative of this part. 2 would come here as it is. Again, this tan square is going to be solved by that bracket rule. Bracket rule is not a term. This is something I used to explain you. that 2 would come here as it is. We will write down the bracket as it is. Tan 2x minus pi by 4. Obviously, we subtract 1. And then we need to write down the derivative of this function. What is the derivative of tan? Yes.
Yes.
And we have to write down?
The differentiation of this, so times 2.
Yeah, so it's 2, right?
Yeah.
Excellent. Next, we simply have to simplify. Sine x cos cube x plus 2 into 2 into 2, that is 8, tan 2x minus pi by 4 secant square 2x minus pi by 4, right? Is it clear now?
Yes.
Perfect. So these were the homework questions. Now I would like to explain, I would like to do a question which I wanted to do in the last lecture, but we didn't have enough time by the end. Okay. So do you still remember the parametric differentiation, which we discussed in last class?
Yes, I do.
Excellent.
We use the chain rule and yeah.
Very good. Very good. Okay. So, just a second. Here's the question. Open. Okay. So this is a question I wanted to do. I think we discussed it in the last class, but we were not able to complete it properly. And it has more to do with trigonometry as well. Okay. And I think you need some help in trigonometry as well, because you told me that you had a, problem with past paper exams. So I just wanted to do this question. Okay.
We didn't do this. We did the one where where it was mentioned the tangent is parallel to the x-axis.
So we have not done this one, right?
No.
Okay, excellent.
No.
So let's do it now. Okay. So the parametric equations of a curve are x equals 1 plus 2 sine square theta and y equals 4 tan theta. And this is a given interval. Don't worry about it. Okay, at the moment we don't have to deal with it. Just leave it. We have been given with x equals to a function and y equals to a function, and we need to find dy by dx. Okay, now things are very obvious. We have been asked to find dy by dx. We have two equations that are in terms of a third variable theta. So simply this is the case of parametric differentiation. Okay, right. Solution. So we know that we need to find dy by dx, and the third variable is, first variable is x, second is y, third one is theta. What is going to be the chain rule in this case?
This will be dy by d theta.
Excellent.
Tan d theta by dx.
Very well done. So you only need to remember this formula. That's it. You are already good enough at differentiation. So you would be able to know dy by d theta. Okay. What is y? Y is 4 tan
Theta.
theta. So what is dy by d theta? 4 secant square theta, right?
Theta. Yes.
Okay, and what is x in our question?
1 plus 2 sine square theta.
Very well.
So that will be
Mm-hmm.
2 times.
Okay, just give me a second. I need to write down this. Excellent. Wait. Yeah. Okay. dx d theta. What is the derivative of x with respect to theta?
2 sine, yeah, 2 bracket
Hmm.
cos theta.
Wait, what should I write after 2?
2 bracket 2 cos theta.
2 bracket 2 cos theta. Is this what you are saying?
Yes.
Okay, so you have missed something. I'll tell you what. We need to differentiate this function. You have missed this 2. Remember whenever we have a trigonometric function and the power over here is greater than 1, this just ignore this 2. This 2 would come here as it is, okay? Next, we need to follow the bracket rule. This 2 would come here. The sine theta would come here. Just like we write the bracket as it is, we are going to write sine theta as it is. And then the
So
derivative of
then
this.
2 cos theta.
Yeah. Okay. So you
Yes.
need to write down sine theta here. Okay. So this is dx by d theta. Okay. So what if I substitute values now? Dy by d theta is 4 secant square theta. D theta by dx is the reciprocal of this function. That is,
Yeah.
sorry,
1 by 4 cos theta sine theta.
excellent. 1 by 4 cos theta sine theta. Can we simplify?
Yeah, you can cancel the 4s.
Okay. And what is sec square? It is 1 by cos square theta, right? So I can write down this thing like this. And finally, we are left with 1 over cos cube theta sine theta. Okay?
Yes.
Is it clear? Is this differentiation
Yes,
clear?
it's clear. Yes.
Excellent. So I'll talk about the second part first. Just let me get a new whiteboard because it's messed up. Okay. Okay. This is what we were discussing. We are done with the first part. And now we are going to see the second part. Okay, why is it shrinking again and again? Right. Is it readable now?
Yes, it is.
Okay. So the answer to the first part was dy by dx was 1 over cos cube theta into sine theta. Perfect. Okay. This is dy by dx. And now let's read the second part. Find the coordinates of point on the curve where the tangent is parallel to the y-axis. So this is the y-axis. This is the x-axis. Now if we have a curve and they are talking about this part. If something is parallel to y-axis, what is the slope in that case?
Parallel to y-axis. Yeah,
The
it won't
slope,
be 0.
this, sorry, it would be 0?
No, it won't be 0. It
Yeah,
will be infinite.
yeah, it will be infinite. I thought you said it would be 0. Okay. So look, these are the two extremes. When the slope is like this, it's a straight line. It is infinite, and if it is a horizontal line, it is 0. Okay. So in this case, the slope is infinite. And what is the slope? The slope is dy by dx equals 1 over cos cube theta sine theta. Now, how are we going to write down this like infinity here, and we'll take it to that side and then
No,
anything
we
on?
can't do that.
Yeah, okay, very good. So the approach in this case would be, if we have infinity over here, whenever we divide something by 0, Either it is 2 divided by 0, or it is 1 divided by 0, or it is 1000 divided by 0, or if it is any random function divided by 0, the answer would be infinity in each and every case. Okay, so this is something that is given. Whenever the answer or the solution of a fraction in this case is infinity, it implies that the denominator, that is cos cube
Still
theta,
zero.
excellent, sine theta, is 0. Okay, so we are done till here. This is 0. When this is 0, it means cos cube
Either
theta
cos cube theta is zero or
or
sine theta
sine
is zero.
theta is 0. And when we have cos cube theta, it is basically cos theta equals 0. Why? Because we can take cube root on both sides and this would be
Yeah,
cancelled. Okay, so
absolutely.
let me just clean it again. So we have first calculated dy by dx, then we have talked about the approach to solve part B, and now after using the approach, we are left with that either cos theta is 0 or sine theta is 0, right? So
So the
what,
values will be
yeah,
cos theta will be 1 by 2 pi and sine theta will be, is it 0?
okay.
I
So
think it's
it's
0.
okay. Excellent, excellent approach. But let me just draw the graphs first because we have been given with these ranges, okay? We need to be careful.
So the ranges.
Okay, this is the cos curve. This is the cos theta curve. So let's talk about these. When is the cos theta 0? Let me write down cos theta here. Cos theta, okay? When is cos theta 0? What are the values over here?
1
This
by
is
2 pi?
excellent. This is pi by 2, and this is 3 pi by 2.
By 2.
This is pi, that is 2 pi, and this is 0. So cos theta is 0 when theta is pi by 2 or when theta is 3 pi by 2. And these two angles are not included in our range, right? So cos theta cannot be 0 in this range. The range which they are talking about is this one. Wait, let me change the color. Yeah, here they are talking about this part only, okay? This is the given part. So here cos theta is not 0. Pi by 2 and 3 by 2 are not included. So we are not going to get a solution from this part. Cos theta is not 0 in this range. Okay, so we have to do something with the sine curve. Let's talk about the sine curve now. This is 2 pi, this is pi, this is 0. So what are the points? This is sine theta, where sine theta is 0. It is 0 at theta equals 0, theta equals
0.
pi, and theta equals 2 pi. Right? It's 0 here, it's 0 here, and it's 0 here. It's 0 at these 3 points. So this is the range 0, pi, 2 pi. Which angle comes in this range? 2 pi? Can we say that theta is between 2 pi in the given range?
Yes.
No.
No, no, it's not because
Yeah.
it's not less than or equal to. It's no.
Yeah, very good. No, even if it is less than equal to, still 2 pi is greater than 3 pi by 2. And our theta is less than 3 pi by 2. So 2 pi is not included. Is 0 part of this range? No, it is not.
No,
Because
it's not.
theta is greater than pi by 2. So this is the only thing which we have. Pi is greater than pi by 2 and pi is less than 3 pi by 2. This is pi. So the answer is
Pi.
Theta is pi. Excellent. But what was the question? The question was find the coordinates of the point on the curve where tangent is parallel to y-axis. So we need
So then
to.
you have to substitute pi to the main equation.
Excellent. So we'll substitute pi in this equation and in this equation. Okay, so what are the answers? Let's just do it. X equals 1 plus 2 sine square pi, and the answer would be 1. Why? Because sine pi is 0, so sine square pi would also be 0, and
Mm.
y is 4 tan pi, right?
That
So
will also be 0.
excellent, very good. So the point would be 1.
1 and 0.
Excellent, right? Is this example clear?
Yes.
Okay, perfect. So let's just discuss the new topic now. So the new topic is implicit differentiation. Implicit differentiation. Yeah, here it is. Open it. Is it readable?
Yes, it is.
Okay. So implicit differentiation, all the functions that we have differentiated so far have been of the form y equals f of x. We have also discussed these types of functions. Remember?
Yes.
Parametric ones, okay? Okay. These are called explicit functions, as y is given explicitly in terms of x. However, many functions cannot be expressed in this form. For example, x cubed plus 5xy plus y cubed equals 16. Now they're saying that we have been discussing questions of this type. Let's say y equals f of x. So let's consider y equals 5x, or maybe y equals 2x plus 1 whole square. We have been discussing such questions where we had this y on the left hand side only, right? So we had y at left hand side only. These were the questions which already had y as the subject. But this is not important, okay? It could be that you have been given with a question of this form where the statement is x cube plus 5xy plus y cube equals 16, and still you have been asked to find dy by dx. In such cases, we use implicit differentiation. Okay, let's read more. When a function is given as an equation connecting x and y, where y is not the subject, here y is not the subject, it is called an implicit function. Explicit function explicit functions are of this type, and implicit functions are of this type. Okay, where you have a function of both x and y, and then there's a number over here, or maybe zero, or it could be a number or something of that sort. Okay, so this is the function. First, you need to understand the difference in implicit and explicit. Then we'll see how to apply implicit differentiation. Okay, so for implicit differentiation, we'll be using the chain rule and the product rule. I'll explain that. You don't have to worry. But first, you need to be clear with the explicit and implicit functions. I'll give you a few examples, and then I'll explain you to those examples. Okay.
Yes. Okay.
Okay, so can you please tell me, this is, wait, I need to change the color. Okay, we have 4 examples, 1, 2, 3, 4. So which of these examples is the case of explicit functions? Which function is explicit function in this case? Or in these cases?
Second one and the fourth one.
So you are saying this 2 and this 4 are explicit functions, right?
Yes.
Okay. But let me tell you again, explicit function is the function that is of the type y equals f of x. So whenever you have a function where y, where you only have y at the left hand side, this is the left hand side, this is the right hand side, those functions are explicit functions. Because what does the term explicit means? Basically, the functions where you have y equals to something that has x is explicit function. In explicit functions, you only have y on this side and x is on this side. Okay, you have, you know how to write y in terms of x in case of an explicit function. So here y equals 2x is an explicit function because y is written on the left hand side and this is the right hand side. Here we clearly have only y on the left hand side and only x on the right hand side. But if I talk about example 1, we have a mixture. We have y square and x. Both of these terms are at the left hand side. Similarly, if I talk about this part, again we have both types of variables on the left hand side. Again, if I talk about this fourth example, both x and y can be seen at the left hand side. We don't only have y, but we have x as well. So this is not explicit functions. These are not explicit functions. Explicit functions are of the type where you have y at one side and on the other side there's a function of x. And when I say function of x, it can be 2x plus 1 whole square, it can be 5x, it can be anything, but it has to be in terms of x only, and we'll have y only in case of explicit differentiation, right? Is it clear?
Yes.
So are you clear with what explicit function is?
Yes.
Okay, so explicit functions are functions which we have been discussing since ages. Implicit functions are new type of functions. Okay, let's just talk about an example. You will get a better idea. Let me just I'll take out the question now. Okay, this is the last question for today. Implicit question. This is the file. Okay. So do you remember that the previous slide had this thing where they said that we'll be using the chain rule and the product rule for solving implicit functions, for calculating implicit derivatives? Do you remember?
Yes, I do.
Okay. So first of all, you need to be very clear that here we have expressions and we have been asked to differentiate them. But these expressions are not in terms of x only, okay? We have y as well. We have to find the derivative of this thing, okay? This is something which we haven't done before. We'll do it now, right? So in this case, we have to use the chain rule, okay? What is the chain rule? The chain rule says that we need to write down the derivative of y cube with respect to y. We'll simply multiply that by dy by dx. And this is how I explained the chain rule to you. This was the function and we were asked to differentiate this, okay? But we cannot differentiate it directly. We need to use the chain rule. And this is the chain rule. First, we will differentiate this thing with respect to y, and then we'll multiply and differentiate y with respect to x. This is what the chain rule says. So the answer would be the derivative of y cube with respect to y is 3y square dy by dx. Now remember, now listen to me, please. If you had a dx and you were asked to differentiate this a cube with respect to x, the answer was 0 because there is no x. You cannot see any x over here. Okay, so you could have said that, ma'am, why are we not writing a 0 directly? Because this
Yeah.
y cube has no x. But remember, why there's an underlying assumption that y is a function of x. You are not able to write down y as a function of x because of some complication, but y is a function of x. And whenever you have been asked to differentiate something with respect to x, where you have both x and y mixed, that is the case of implicit differentiation, number one. Number two, you can never ever write down 0 directly because y is a function of x, okay? There is some x in this y which you don't know. But if you get to know that, you simply need to derivate that with respect to x, and this is how you have to solve it. Okay?
Yes.
Okay. Let's talk about the second example. 4x square y cube. Okay. Now again, this is a mixed question. In previous examples, the questions used to be of this type: derivate 4x square only. This y is a new thing and we need to solve it. Okay. Anyhow, y is a new thing, but we know whenever we have two functions, 4x square is a function of x and this y is also in terms of x, I've just told you. So again, we have two functions. We have two functions. Both these functions are in terms of x. 4x square has x, that is obvious, and y to the 5 has also x in it because y is a function of x. I've just explained that, okay? So we have to use the product rule first of all. So 4x square would come as it is. Derivative of y cube, y to the 5 would come here, plus the second function, that is y to the 5, that has x in it, would come as it is, and we need to differentiate 4x square over here. Okay? Okay. Then we have to simplify things. This 4x square would come here as it is. The derivative of y to the 5 with respect to x is going to be this. Okay? For this, just like this question, we need to use the chain rule. The chain rule says that we need to write the whatever function we have by dx into dy by dx. I'm sorry, just let me just. The rule was d whatever function we had by y into dy by dx. Okay, this is the chain rule. This is the chain rule. We need to use chain rule for this part. So by using chain rule, we will get 5y to the 4 dy by dx plus, we need to simplify this part. Y to the 5 would come as it is. The derivative of 4x square is simply 8x, and this is the answer. Okay? Okay, it is. I am
Yes,
sure
okay.
that this is very confusing for you. We just have 2 more minutes. I'll just take a simple example. I'll try explaining you, and rest we'll discuss in the next class. Okay. Again, I'll explain you by first talking about the difference. In past, we have been discussing questions of this type, right?
Yes.
And now the question is of this type. Here we simply used to write 8x. But here, first thing, y is a function of x. So you cannot just ignore this y. This is a function of x. Two functions of x are being multiplied. We'll use the product rule first, okay? So the product rule says first term as it is, derivative of the second one. Derivative of the second one plus second function as it is, derivative of the first one. Right.
Fine.
So 4x square would come as it is. Now this is dy by dx. We can either use the chain rule or we can simply write dy by dx here directly. Okay, but if we use the chain rule, what is the chain rule? The chain rule says we need to find the derivative of this function with respect to y, and then we need to multiply it by dy by dx. Right? So derivative of this is basically 1. So we are again left with this dy by dx plus y would come as it is, and derivative of 4x square is 8x. So if we simplify it, the answer would be 4x square dy by dx plus 8xy. This is how we are going to solve this question. Okay, so the time is up. I'll explain this concept again in next class, and then we'll talk about some more examples. But at the moment, the only thing I want you to remember is that this is the simple differentiation, and we will solve it through implicit differentiation because here we have y with this function. Okay, that's not a function in terms of x only, we have y as well, and this y again is basically a function of x. I'll show you some examples. This implicit differentiation is not to confuse you, but it is used in those cases where you cannot make y the subject of the equation and still you want to find dy by dx. Okay, there could be many cases where you are not being able to where you are not being able to make y the subject of the equation, but still you want to find dy by dx. In those cases we use implicit differentiation. Okay, I'll talk about that case directly in the next class, and we'll see how to solve and how to deal with those cases. Okay, right?
Yes.
So do you want to ask me something?
No, it's fine.
Oh, are you sure?
Yes, it's fine.
Okay, so I'll end the recording and I'll see you tomorrow.